Hello and welcome to another video. Today we'll be deploying serverless applications with AWS Lambda and API Gateway. For those that are unaware, serverless computing is a model in which cloud provider allocates compute resources on demand. Serverless applications normally use functions to provide application logic as well as other specialized services for additional capabilities. This can include things such as messaging queuing or even data storage. As we can see from the architectural diagram, we'll be deploying a Node.js function to AWS Lambda, then exposing that function to the internet using API Gateway. The S3 bucket stores the Lambda function as a bucket object. The IAM role is assumed by the Lambda function for execution. The IAM role will also have a IAM policy, which is the Lambda basic execution policy role attached to it. The Lambda function will have the runtime Node.js and handler as hello handler. The logs from this and the API will both go to the CloudWatch log. Within the gateway, we also break down the Lambda stage, integration, and route. The Lambda permission allows the API gateway to invoke the Lambda function and then exposing it out to the internet. First, we can have a look in the AWS console, see that nothing's currently being created in either CloudWatch or Lambda. Let's move over to Visual Studio and have a look at the JavaScript file. The JS file is a simple response message saying hello world. Now we need to create the Terraform provider and variables file. And the default region, we want to put this into US West 2. Now we can reference this within our provider file. As always, this will be available on my GitHub. Now that we've created those, we need to create the main file, which will then start on creating the bucket and the output. For the output, we're just going to put the bucket name. Description is going to be name of S3 bucket used to store function code. And also need to specify the value, which is going to be S3 bucket, make it lambda.id. Need to remember this because I'm going to use it as a continuous reference, so I'm going to keep it simple as this. And now to get started on the main file, first resource we need to create is the random pet for the bucket name. Let me create some of it first and then describe it. Yeah, prefix learning Terraform function, then the length of it should be minimum 2, but we're going to make it 4. So this generates random pet names that can be used as unique identifiers for other resources. This allows us to prefix the bucket name because, as you well know, with S3 buckets they need to be individually unique, so this allows us to circumvent that error. Next, we need to create the S3 bucket, which is going to be the Lambda bucket. We can reference the random pet name that we've just given it as well. So just copied that so I can make quick adjustments. And then to specify the bucket, it's going to be the one where you just put in output. Double checking. That's okay. Next, we need to create the ownership controls, again relating to the Lambda bucket we've just referenced. The raw object ownership, I'm going to have this bucket. So next we need to create the resource for the S3 bucket ownership controls. I'm going to have this set up as, see if I can show you in the visual. So anyone that puts anything into the bucket, the ownership of those objects within the bucket goes to the bucket owner, which is essentially ourselves. With this, the JS file that I put into the bucket, or whoever puts into the bucket, it then becomes my object, as in I have ownership of it because I own the bucket. Gonna be for the Lambda bucket. For this, again, need to reference the bucket and also need to specify the rule I want to implement. So the object ownership as described. This is going to be bucket preferred. The object belongs to whoever owns the bucket, regardless of who puts anything within the bucket. Now for the next resource, it's going to be the bucket access control list, or ACL, and then it's going to be Lambda bucket again, and this access control list is going to be dependent on the ownership controls of the Lambda bucket. Again, need to specify the bucket. And finally, the access control list is going to be private. Alright, so let's save that. Now we can initialize and apply this just to create the bucket. Does not match. Okay, need to upgrade it. When it's created, we should be able to see it in there. Okay, a few errors. S3 Lambda has not been declared. Okay, I see the issue. It's because of the resource random name. I didn't actually put random. I've just put a random. I've put AWS instead of a random bucket name. So yeah, I just need to readjust these. Bucket and then .id, and then if I change that for the, and this one, it should be Lambda bucket as specified here, and AWS bucket, yeah, Lambda underscore bucket .id. Let's just resave that. Let's clear and apply again. Okay, so line 4 still an issue. Oh, it's outputs. AWS bucket. It's underscore bucket.id. So yep, so it's AWS S3 bucket, which is the resource, and then the resource name should be Lambda bucket. Okay, great, that works. We can see it currently plans to perform the following actions. Lambda.bucket will be created, the bucket ACL will be created, ownership, and the random pet name. Okay, so value yes, clearly actually solid raccoon. So this was the random pet name prefix of length 4 that we've given it, so that the bucket is unique across all AWS, so that the bucket is unique across the whole of the AWS. If we refresh, okay, great, we can see the buckets here. Properties, nice. Permissions, block all public access, great. No access point. Alright, great, so the bucket's here ready and waiting. We can now send the archive file to the bucket. We can now send the archive file, which is the JSON or JavaScript. Okay, so now the bucket is up and running. Let's send the archive file, which is the JavaScript, to the bucket. Ideally, we would want to make this a zip file. The source directory will be the current directory for me. Okay, great. So the data archive information has been created. We want to make this a zip file. We want the source directory to be the current directory, which is .terraform and then the hello world folder. And the output path is going to be within the bucket, and it's going to be named as hello world.zip. The resource that it's going to go to is the bucket, and the key for it is going to be hello world.zip. The e tag is optional, but it triggers updates when the value changes. We're going to use this later when we update the JS code file to say different things. So in all, this is to create a bucket object of the archive file, which is the JavaScript, and upload it to our S3 bucket. We can save this, we can terraform, apply again, and then we can check our bucket. Okay, yep, so it's been put in the S3 bucket. So let's list the bucket first of all. We want to list inside of the bucket. Great, we can see that this has been uploaded successfully. Next, we need to create the Lambda function. So first resource be AWS Lambda function, and we want to give it the name of, we'll go with hello world. The function name will be hello world, and the S3 bucket will be the one that we just described previously. And the S3 key will be it would actually be an S3 object. Yep, perfect. We need to put .key to make sure it's specified as a key. Also need to do the runtime, there we go, and handler. So this is going to be node.js 20.x hello.handler. Source code hash is going to be data archive file lambda hello world. We need to make sure this is an output, specify the base 64, and the role, this is going to be AWS imrole.lambda exec, because that's the execution name we're going to give it, and then the ARN, we should be able to find that within the IAM console. A resource source will be AWS CloudWatch log is where we want to send it, and then group hello world. And the name and /, and we also need to specify how long we want the logs to remain for. I thought it would have popped up. Oh, it's 30 days. So that's the CloudWatch resource created. This is still an error. What am I missing? Oh, it's the equal sign. Okay, great. So I've specified the role, so I need to create a resource for the role. Or I've declared the role. No, I've referenced the role, so I need to declare it. Nice. And then this will be a lambda exec or lambda execution. While we're at it, let me create the resource for the attachment policy. Nice. It's going to be lambda. So the name for this, serverless lambda, which is what lambda essentially does, and JSON should be encode, JSON decode, yep, so JSON encode. Okay, so that's the lambda role specified. Now we need to do the attachment policy, which is role AWS site. We need to also specify the policy ARN. There we go. Let's have a look here. CloudWatch logs. Yeah, that's the object execution one. Let me see if I can find the. There we go. Take a look at them both. Okay, basic execution role, just for the CloudWatch, and this one's for S3 object buckets. Alright, great. And then that should be it. Let's save that there. Yep, so I've chosen this role because we're going to be using the S3 object bucket as well. Or, yeah, so S3 object within the S3 bucket, so it made sense to have something like this. Could have given it admin role, but you wanted to make sure we're still coordinating with least privilege, which means we also need to add this to our output file. So we need to output the function name, and then let's give it a description, and we also need to specify the value for it as well. It's going to be AWS Lambda function dot hello world dot function underscore name, as we've just described it there, function underscore name. Alright, that's great. Let's save that. And now we can see, first let's terraform apply this so that this can now be created, and we should be able to invoke this from the command line. Okay, great. So let's AWS Lambda invoke region equals US West 2, I think. Yep. Function name, and then we need to specify the terraform output. And then confirm. Okay, great. Execute versions, the latest, code 200. Let's concatenate this response.json. Status code 200, application, hello Oakland codes. Okay, great. So we can confirm that it's been uploaded, the object's been uploaded to the bucket, and we can access and invoke the Lambda function for it because we've got the permissions. Now that it's been invoked, we should actually be able to, great, so you can see the log group there, the retention's 30 days for 1 month. Alright, so we know that's up and running. Alright, now we need to create the HTTP API with API gateway. First resource is going to be AWS API gateway, and then it's going to be Lambda. Name of this serverless Lambda underscore gateway. We need to specify the protocol as we want it to be HTTP. We need to create additional resource. We need to create additional resource for the stage integration and things such as, and saying we want it to go to the CloudWatch logs. Okay, so these have been created. To specify the API gateway. The API gateway allows for us to create and manage HTTP or WebSockets. It integrates very well with the AWS Lambda function to handle and respond to HTTP requests. The API gateway v2 stage sets up application states for the API gateway, such as testing, staging, and production. The example configuration defines a single stage with access login enabled. So the API integration maps a HTTP request to a target, in this case our Lambda function. In the example configuration, the root key matches any GET request matching the path /hello. And finally, the CloudWatch group log defines a log group to store access logs for the gateway API stage.lambda API. And these are the permissions for the API gateway. This allows us to invoke our Lambda function, and we also need to add the base URL into our outputs. Okay, so now we've added the base URL for the API gateway stage to our output file. The API gateway stage will publish the API to a URL managed by AWS. We also need to add the output value to this as well. Actually, first let's test this. Okay. This should be Terraform output raw, and then base URL, and we want it to be here, get /hello. Great. Okay, so now we've just called the Lambda functions via the API gateway's proxy integration. The API gateway passes the request information to our function via the event object, which we can use the information about the request to our function code. And now, as I mentioned with the E tag, where is it? We can now update our code, the JS code. If we were to add if statement here, wrong button, say if the event query string parameters and event query string parameters name response message equals hello plus event query string parameters, and then close it off there, and keep the return as 200. Let's Terraform apply it first. Yep, so you can see the source code hash has been updated, which confirms that. Alright, great. So if we use this again, but instead if we say name equals Terraform and then close it off. Let's see. Okay, nice. So now we can see the message has been updated to hello Terraform. Alright, wonderful. Yep, so we can always try with different names as well. Let's try YouTube. Lovely. So hello YouTube. So yeah, we can see that we can send different requests to the function, including the name, query parameter, and it automatically updates and allows us to run those. So thank you for watching, and I hope you enjoyed it. Please don't forget to destroy any resources created. And I'll see you for the next one.